So in this video, we want to show you how to actually simulate the circuit. I'm going to close this menu here so that we unclutter the screen a bit. So here's the circuit that we drew in the previous video. And in order to actually get answers for currents and voltages distributed throughout the circuit, we have to put in some probes. So that's this little V here, which is short for voltmeter. And we can measure voltage, we can measure current, we can measure voltage and current. We also have the option to put in a voltage reference. I have put in a ground, so most versions of Multisim don't need then an additional voltage reference. Some do, some don't. I think in this case we don't need that since we chose to select one of the nodes to be our arbitrary ground. All right, so it's important to know that when I place this voltage probe, I'm going to measure the voltage between here and ground. So I'll put it right there, and you'll notice immediately it has given me an output of 120 volts. So where is that 120 volts? It's between this point where I placed the probe and where I identified the ground. Okay, so the other thing that we want the current through these two resistors, and we want the current through this resistor. So for those two, we'll select the current measurement. And now it's possible when you draw a circuit in Multisim to connect a bunch of resistors together in series without a wire. Multisim will allow the endpoint of the resistors to connect with one another. However, if you're going to try to measure the current through a resistor, you need to have at least a short segment of wire. So you notice as I move this current sensor around, I don't get my characteristic little red dot until I get down here on the wire. And my wire in this figure is kind of short, so it's a little bit hard to get the thing right there. So I might have been better off making this particular wire a little bit longer in my original drawing, but it's going to work out. So we'll put the current meter right there, and then we'll put another one over here. Okay, and so you notice now that everywhere I have a probe placed, I'm getting a value. So I have 300 milliamps through these two resistors. I have 1.2 amps through this resistor. I have 120 volts from here to ground. I can, just for the heck of it, if we want to put in another voltage measurement, I can do that. I can put that right here. Okay, for whatever reason, it's not taking that one. So because we're choosing a DC operating point, a lot of times I may not be fully connected here. Let's see. Let's try that again. Oh yeah, you can see I was here on the tip of the resistor instead of actually being on the wire. So let me see if I can get in right there. There we go. So this arrow here is basically running your simulation. So you notice that when I placed my first voltage probe and my first two current probes, I got numbers immediately, but then when I placed this voltage probe, I didn't get anything right away. So in order to get it to give me a value, I pushed the run or simulation, and it basically just recalculates everything. So if this starts to get too cluttered, I don't think there's really a way to move this display. I believe on the actual downloaded and installed version of Multisim, you're able to move these numbers a little bit. So the other thing you can do is you can go to a different menu, which is the grapher menu, or you can split it. So right now what I'm showing in my window is I'm showing the circuit. I can split between the schematic and the grapher, and you can see what it's going to do is it's actually going to give me a summary of what all my values are over here in this nice chart. All right, so on your project where you're going to do several simulations, what I want you to do is I want you to get this kind of display and hopefully you will do yours a little neater so that you don't have your things overlapping here, so it's kind of hard to see. But I want you to do this kind of a display, and then I want you to also show the output. So I can come in, because I'm on a Mac, it's pretty easy to do a screenshot. I can come in here and I can highlight this, and these you can actually output. So I can output a schematic image, I can output the data to a CSV file. I don't know if any of you have ever used CSV files, but it's kind of generic. It's comma separated value is what that was originally short for. You can open it with Excel, you can open it with most spreadsheet packages, and it'll just open it into the spreadsheet. So you could output that, or you could do a screenshot on that as well. So I'll just do a screenshot here since I'm using the Mac. And then you can open a Word file and import your screenshots into your Word file for your project submission. Or if you want to make a PDF out of those screenshots, if you have the full version of Adobe, that's pretty easy to do as well. But this is the kind of submission that I want you to do. And like I said, hopefully you can spread your elements out a little bit more. So now what I want to do is let's do some things with this circuit. Let's reproduce it and see what happens if you combine these two in series. And what should happen is that the current value should be the same, but of course this location for this voltage probe will go away. So you can actually, on this single schematic page here, you could actually create a complete other circuit. So you can copy, by the way, your elements. So let's go back and show you how I did that one more time. When the element is selected, you can get this button on the lower right hand side and push it. It'll duplicate the element, it'll duplicate all the values. So if I were going to combine those two resistors, what that would do, come on. What that would do is that would put these two in series, and so that would be 400 ohms. So let me go back to just my schematic view, and this little guy right here opens the configuration window. So I'll put 400 ohms here, and then, and you notice now, oh, it doesn't like that. It's going to tell me my simulation is out of date because it doesn't know what I'm doing. And then I'll put, what was that, 100 here, and I'll put 1.5 here, and then let's do some connections. So I want to not make the mistake I made last time. Let's give myself a little bit more, oh, come on. Okay, there we go. Let's give myself a little bit more room when I draw my connectors, when I draw my wires. Okay, and then I should be able to pull that up so that I get more space here to put my current measuring device. And then we'll choose another current meter. So we'll choose another current meter. Oh wait, I guess we can put the current meter here. And let me wire from here to, sometimes on my Mac the trackpad is kind of weird. And then I'm going to need to wire the bottom. Let's try that again. There's that one. And it's a little bit of a touch thing. There's that one. And then let's put one more current meter right here. Now I think this one, since I'm not asking it for a voltage, I think this one is going to run the simulation without the ground. So we'll just try it and see. So let's push this arrow key here. All right, and you notice, even though I've got two completely separate circuits, it ran the simulation for both. And if I split the view, you can see that basically what it's done is it's assigned a PR value, that's short for probe. So it's showing where my probes are, and then it's showing for each probe what my currents and voltages are. So what I've just done here in this little demonstration is that I've proved that if I replace the series combination of the 150 ohm and the 250 ohm with their equivalent of 400 ohms, I get the same currents through each of those branches. So that kind of shows that the current through elements in parallel or in series, I can replace them with their series combination. I still get the same current. This voltage here that was shown up here with probe, I believe that's probe 4, the voltage that was shown with probe 4, it's gone because this point in the circuit is gone because I combined these two elements in series. So that's a demonstration of how we would simulate a circuit on Multisim. And so on your project, I'm going to ask you to simulate several circuits. Sorry, like I said, my trackpad is doing weird things here. I'm going to ask you to simulate several circuits. These plus and minus keys over here will change the physical size of your circuit. So if you want to make them bigger or smaller, you can do that up here. You can make this window go away by re-clicking on the toolbar window. And so for those of you who are in regular circuits class, this can be pretty useful because it can allow you to do several different things. There are even I'm trying to find in this system, in this particular simulator, I'm not sure that we have dependent sources for the benefit of those of you who are in circuits. You may have to go in, let's see, if I open the toolbox on that, I'm not seeing an option to make this a dependent source. So that may not be a possibility in the online version. If you get if you get the version from the download, it'll allow you to do that. So anyway, hopefully.